Okay, everybody, the wait is over. We will go live in a few minutes. But before that, let's wait for a few nice music.
I found someone new now. I have more room, no more formats to chain me. On the same page, we are effortless, schemaless, living in the future, you and me, made for us, serverless, living in the future of the clouds.
Okay, good morning, good evening, good afternoon, everyone. Hope everybody has a good time today. We are together for 2 hours. Okay, so before starting, just audio sound check. Can you give me a sound up just to see if everything's okay in the chat? Or let's see, we are 36 people. Okay. All right, I think we are all good. All right. So I'm Cedric Lunven and I'm leading the developer advocacy team at DataStax. I'm a trainer, public speaker, Java geek, all about coding. We are together for 2 hours. If you want to join my network, feel free to invite me. This is my coordinate, LinkedIn, Twitter, and GitHub. So it's not only me on screen. We also have a huge team, a big team that helped me create this content. Actually, this content today has been created mostly by Aaron Plutz. And also Stefano is with me today, helping in the chat if you have any question. But it's not a single man effort, it's a team. We are here every week, same time, to present you different kind of content. We are live on YouTube. So you can interact with me, of course. You can ask questions on YouTube. I'm reading the YouTube question right now. But when the session is over, and if you're actually watching a recording of this session later, you can still ask us questions, but this time using Discord. We do have about 20K people in this Discord room. But to be honest, today I will mostly check the YouTube chat. Also, it's an interactive session. It's not only me going over slides. First, it's technical, full of hands-on, and we will do some interaction. I will ask you questions as well, using something called menti.com. And you know what? Why not start with that? Okay, so, let me ask you a couple of questions. So to do so, open a new tab, go to menti.com, and I will wait for you here. So right now I'm on Menti. So please go to menti.com and use the code 2256 32346. Okay, I put that in the chat. Let's see, and I will wait for you here. And you know what? Let me see if we do have these. Okay. All right. So let's see. We do have about 46 people in the live, and I only see 12 people here. So we are together for 2 hours. We have time. I can wait a little bit. Okay, so my first question for you is simple. Where are you from? See, Europe, USA, hey. So yeah, thank you for joining. I mean, it's the World Cup. Maybe you would be able to watch some soccer match. I think the French is France is playing against Tunisia right now. So thank you for joining. Oh, I see people coming from India. It must be late for you. So, you know, I will make sure to be done in the 2 expected hours. But look at that, all across Europe, USA. So see, it's a truly distributed community. So second question for you, what is your primary programming language? Today, we will have an e-commerce app. The front end is JavaScript. The backend is Java. But I told you, we are here every week sharing new content. So depending on what you do, we can produce more content for you, right? Oh, I see also in the chat, Barcelona, where are you from? Python, JavaScript, Java. So to be with me on and answering the question, it's written at the top of the screen, menti.com, and use the code, and you will see the screen and will get the question. So not a developer. So the session is fairly technical, but even then we will have these use case just for you to get what you expect from an e-commerce app. And last question, what is your experience with NoSQL? So NoSQL database is different from relational. Today I will explain you what's the difference, when you should consider to use NoSQL or stick to relational database. We love them, but sometimes, okay, I have some experience, never use it. So hopefully at the end of the session, you will grasp when you would like to use them. Java, TypeScript. Okay, let's see. Hey, look at that. A lot. All right. So see, have you attended a previous e-commerce session workshop? So it's not the first time we are playing this workshop. And just for me to know if you already joined a session. So, okay, most of you did not, and that's okay. That's okay. So I will cover every pieces. Okay, you know, I wait for you to answer. Okay, 24, I think 26. I've already get an answer. So that's expected. That's great. That's great. Not for now, but at the end of the session, we will play a game together just to see if you pay attention during the session and see who is the best among you. So stay up to the end if you want to play with me to the game. Okay, so I told you it's the technical session. You will have some hands-on to do. I mean, it's not mandatory, but it's if you want to have hands-on with me, go for it. It's not marketing, fully technical, but you do not have to install anything. Everything is provided to you web-based. So the database is web-based, the ID is web-based, and everything you need, the instructions, the code, even the slides are on the GitHub repo. Okay, so and if you use some command like bang GitHub, the YouTube chat will show you where to look at. So bang GitHub will give you the link, but I will also copy paste the link anytime it's needed. Okay. Also, this is a tradition in this live weekly live workshop. If you complete all the hands-on, do a screenshot, send the screenshot to an email address I will give you at the end, and we will redeem you a badge, you know, to brag on LinkedIn. There is no certificate just to attend the session, but if you complete the hands-on, you get this badge, and the badge can be shown on LinkedIn. So pretty cool and not hard to do. We just follow the instruction and submit the screenshot of your e-commerce app running. So that's the agenda for today. We are at 8 minutes in, and I think we can cover all this content. It's a lot, but you know, the idea is really to be straight to the content. So first, e-commerce application design. What are the technologies we picked? And then layer by layer. What about the database layer? What about the service layer? Broadening the code and adding some extra features in the app like authentication. And at the end, the game. Okay, so what about the design? When you create an app, good practice now is to have a web UI, because if you provide a web UI, then your users can use your app either with mobile or web or progressive app. Some solution like Discord, even if you think you install an app from the store, App Store or Google Play, actually you mainly download just an empty shell, and under the hood it's just a web app. And that makes sense because it's super easy to then update the app without having to update the App Store. So today we do the same. We have a 3-layer app, so pretty common. Front end, back end, and database, so 3 tier. For the front end, really what is trendy now, so ReactJS, that's the framework we will use. Node.js, the environment to run this code when we develop. On production, this React is rendered as vanilla JavaScript, more or less, so you can even run that on the web browser, no need for Node anymore. We are using Tailwind CSS, which provide us a couple of components to use and nice UI features to have a nice looking web app. So JavaScript, CSS, HTML, as you expect, React Node. What about the backend? Well, which technology we would pick? So I told you for the front end, web on mobile, JavaScript, Angular. Angular or React, here it's React. For the backend, we want to expose some services for the front end. We want to create a REST API. And I'm a Java geek, so let's go with Java. And with Java, 3 main frameworks to build the REST API. Spring Boot, Quarkus, and Micronaut. The 3 are awesome. This time I picked Spring Boot, but on this channel we have content on Micronaut and Quarkus as well. And in the GitHub organization, you will find a couple of content on others. So Spring Boot, all right. So backend, Java, Spring Boot microservice using Spring MVC just to expose a REST API. And for the database, well, here you saw the title of the workshop. We want to use not only SQL, we want to use NoSQL. The idea is, we want our big e-commerce app to work with millions of connected users and handle dozens of thousands of transactions per second. So for that, we need a very strong database, something that can handle very high workload, high volume, high throughput. And this is where NoSQL makes sense, right? And which database we will pick? We will pick Apache Cassandra. I will explain you what it is. And I told you, you will not have to install anything, including the database. So we will have Cassandra available for you in the cloud using Astra DB. And of course, everything I showed to you is free to use, okay? We won't ask you to any credit card or charge anything, of course. Now on in the futures, everything we do here is free. So go back here. So what about the database? Cassandra. And we will use Astra DB, where you will find Cassandra as a service in the cloud. Okay, so that's the overall technical architecture we will have. But how do we proceed? Well, we will first go to the data layer and then go back to the service layer and then go back to the presentation layer. Why? You will see in a moment, but when you build a NoSQL application, what you need is to create your data model based on your queries, based on your use case. So start with the data model, start with the database. Okay, so plenty of technology to cover, plenty of things to go through. Let's get rolling. Cassandra and Astra in a nutshell, the database we want to use, right? So Cassandra, Apache Cassandra, created in 2008, is a distributed NoSQL database. You can install that on a single machine, single node, and you will get a capacity about 2 to 4 terabytes, throughput 3 to 5 transactions per second and per core. Nowadays, machine got 8, 16, 32 cores, so you can easily have 50K transaction per second on one machine. But it's the distributed system. We expect you to install Cassandra on multiple machines, multiple nodes, as you can see in the pictures. And in this deployment, there is no master. It's peer-to-peer communication. The data is distributed across those nodes, and the same data is replicated on multiple nodes. The idea here is you can lose any of the node. It's not a big deal because there is no master and the data is replicated. So even if you lose one node, who cares? The data is still available on another node. Those nodes can be grouped logically. This is the big black circle here. This is what we call a data center or a ring. This deployment, this is what we call a topology. Okay, all right. With this Cassandra, with this topology, what we can say is, hey, it's big data ready. Read and write performance are super high. It scales linearly, high availability, self-healing, geographic distribution, platform agnostic. So let's have a look. Technically speaking, why we can say that? Yeah, as a philo, it's totally decentralized. So in Cassandra, you will store tables. So there is a schema. You know, sometimes you meet someone on the street and you start talking about NoSQL, and everybody consider that NoSQL are limited to document-oriented database, the one you work with JSON and schemaless, kind of schemaless. It's not the case. In NoSQL, of course, you have document-oriented DB, but you have also database like Cassandra. It's called column store or graph database or key value. Cassandra fits in the category called column oriented. So in Cassandra, there is a schema and you will store table. Those tables will have a primary key, and this is what you expect, a primary key to ensure the unicity of a record. So far, so good. But there is also another column, actually could be a group of columns, called the partition key. And based on the value of this partition key, the data will be saved across the nodes. So here you can see, even with these tiny table, 10, 15 rows, you see the data is distributing like that. And even with that, 15 minutes in, you can say, it's not a good idea to do select star from a table, because that means you will have to get a piece of your result on every node. This is what we call a full scan cluster. It's not working very well. What you want to do is to execute a query where you provide a where clause, and in the where clause you provide the partition key, because then you can access to one node, retrieve all the data from your request staying on one node, and go back. This is the way to ensure high performance. You save together what you want to retrieve together, and you will shape your table based on your request. So in that particular use case, I knew that the request needed would be maybe retrieve all the cities for one country, because one country is my where clause, country is also my partition key. And with that, I can have so many cities in the world. It's easy to get, hey, give me all the cities in the USA. I will go at the node at the top, retrieve everything and back. Okay. This is how you scale actually. So this is a cell. This is the smallest unit. A row. Okay, you got the ID. And rows can be grouped as partition. All the rows with the same value for the partition key is called a partition. All the rows part of the same partition is on the same node. Okay, I think you got the idea, but that's important because when you get that, you will understand why we chosen this data model against another when it comes to e-commerce. And the structures is a group and rows and partition. Okay, so with Cassandra, if you need to scale, you need more capacity, more throughput, simply add new nodes. And so how much can you scale? Well, this is some screenshot from conferences done by Apple and Netflix, and it's even outdated. Apple communicated this year that they now have 300,000 Cassandra nodes. Everything starting with I something in Apple actually stores some data on Cassandra. So why I show you that picture is just for you to understand how much it can scale. And actually Cassandra has been created at Facebook because at some points it was not performance enough with a relational database, maybe on a single machine. They are really to scale, and scaling with relational, it's not that easy. You have to make some hypotheses, and you have to what we call shard, and this is you to decide how the data is replicated. It does not scale easily. In a Cassandra cluster, you can have one ring, but you can also have multiple rings. And you can read and write from any node. Remember, there is no master. So the idea is the data is close to the user. The latencies are low. So when you interact with your e-commerce portal, you want your image to load super fast, you want your data to load super fast. So if the data is very close to the user, latency is low, the application is performant. Now you can read and write from anywhere, and this is the job of Cassandra to replicate the data for you. You don't even have to do it. That's the job of Cassandra to replicate. What you can do with geographic distribution, you can also do the same with technical distribution. You can have one ring in any cloud provider, hyperscaler, also one ring on-premise. And technically speaking, it's possible to have a single data layer available across the cloud. So pretty cool. Okay, last but not least, Cassandra is Apache Software Foundation. So there is no chance of changing the license anytime soon. So that's pretty convenient when it's come to some database has had to change the license. Because to protect against Amazon, who was selling their product without giving any money to the original database product. With Cassandra, no problem with that. Okay, so in a nutshell, if somebody asks you what is Cassandra, well, high availability, always on, linear scalability, hyper scalability, low latency, global distribution. I hope that with the couple of slides before, you get why we say that with Cassandra. So now for today, I don't want you to install Cassandra, so I will give you Astra in the cloud, and it's called Astra DB. Yeah, I will skip this one. This one as well, this one as well. Let's go into the end zone, because I want you to realize how easy it is to start a Cassandra cluster of 3 nodes just with a couple of clicks. And for DevSeed, yeah, I will share the the music URL at the end. It's free. It's also available on YouTube. Okay. So for the hands-on, I'm moving my screen here. So hopefully I'm not hiding anything on screen, and you can see where I am. So let me copy that URL in the chat. Okay, so this is the README, and there is no magic here. I will simply follow the instruction in this README. Oh, by the way, before starting, I told you in GitHub you have everything you need. It was not a lie. So here in the GitHub repo called Workshop e-commerce app, here you see a lot of slides, including the one I presented today. You see the code of the UI, the code of the backend, everything is there. In 2 hours, it's very hard to do live coding and actually do the app in front of you. But here I do have all the code ready to run. I will do the operation to set up the database with you, set up the app with you, and browse the code to explain you what it does. And you have plenty of time after the session to go back and see exactly how things have been done. So for the homeworks, get the badges, table of content, production. Don't want to read. Here we are. Hey, we are together to do some technical stuff. Yeah, so even if you fluent in Python, of course you can follow. There is no tricks. It's just actually applying the commands that they ask you to do. There is no technical difficulty. And this API has been built with Java, but again, go back to the organization DataStax devs, and here we'll see a couple of APIs as well implemented with Python. And maybe I'm mistaken, Stefano is listening, I'm sure, but I think we have samples both for Django and FastAPI. Okay, so first is to connect to this Astra DB to get us a database running, right? So you can sign in with your Google account. Sign in. Let me pick one Google account over here, and it will load. Okay, so the link is just there. Okay, just click that link and you will get directed to the Astra homepage. So I will go to my demo environment, if you wish, DataStax Dev Workshop, the one we always use in the team. So here you can see I already have a database. This database is called Workshop, and the database is hibernating, because the solution is free to use, up to 80 million queries a month, and if you don't use it for 48 hours, it will go hibernated. So if for some reason you already had a database called demo, which is hibernated, the way to resume a database is as easy as clicking resume database, and it should start resuming. Okay, so it's red, but don't worry, it's resuming. But today, what we are told to do is to create a database called demo with the Keyspace e-commerce. So I go to create database button. Here, the database is demo, and the Keyspace is e-commerce. So what is a Keyspace, you might ask? So, of course, a Keyspace is like an Oracle schema. The best practice is to have one app, one Keyspace, because Cassandra is a big architecture, right? A lot of nodes, a lot of rings. So multiple applications will eventually use the same Cassandra cluster. So to split application, what we tend to do is create one Keyspace per application. Okay, so demo, e-commerce, I think I'm good. I also advise you to use the same values here. Of course, it's not mandatory, you can use whatever you want, but later, when the app will start, this is exactly the value that it expects. It's not hard-coded, it's a property file. You can change the value, but the default value is e-commerce. So if you do not want to have to change too many settings, just stick to the default values. Okay, so here database demo, Keyspace e-commerce, and for the cloud, no big change, right? It's free. Just pick one cloud which is free. So here I select Google North America, and here you can see I have some region with a little locker. It's not open to the free tier, the free usage. I don't want to unlock the region. I will simply pick the one with no locker, just to see, hey, I don't need to pay anything and can use this one for free. Okay, so Google North America and Monk Corner. And here I create a database. And see, I provided 3 fields, and the solution will create me a full working 3-node Cassandra cluster. So pretty cool. Okay, it's starting. Also, maybe you will be asked to use the new user interface. Well, for these 2 hours, the instructions are written with the existing UI, not the new one. So would probably be easier to stick to the same UI as me. Do not switch to the new UI, just not to be lost in the instructions. This new UI is, as of today, beta. If you use it, please provide feedback. The team at DataStax is really willing to get this new user interface as good as possible. And look at that. Now my database is active. You have this blue, not blue, green message stating that my database is ready to go. So to go back to the home, I'm just clicking on the DataStax Astra logo. Oh, so you do not see any unlocked DC region. So click Google. See, when I create a database, just for seed, when you select Google, North America, I'm sure you get the first one here. Maybe you pick Amazon and you do not see anything, and Microsoft, you do not see any free one. Yeah, the free one is Google, North America here, or Europe. See, you have also a free one in Belgium. Asia Pacific, you have also Mumbai. Okay. So I do have my database called demo ready to go with the Keyspace e-commerce here. Okay, so let's keep following the instruction. Okay, not rocket science. Here you have an instruction on the left part of my screen, and I'm just following the instruction. Okay. So the database has turned active. Yes, it seems like that's the case. If I look at my here, it's active as expected. So here, see, my database is active. So go. What's next? So okay, the next thing is to create some a streaming tenant. So our e-commerce app have a functionality called order processing. When you order some product, you know, and complete your order, an order is created and a message could be sent outside. And to do this message sending, we are using something called Apache Pulsar. Not the main focus of today, but to have the full app running, we need to set up this Pulsar environment. So again, I'm just following the instruction. Create a streaming tenant. So create stream. Here it is. Enter your tenant. So be careful. This tenant name should be unique across everyone. So do not use the same as me, but you know, define something probably e-commerce dash, and maybe your first name, maybe something that make it unique. Let's use Cedric 2. I don't know. Hopefully Cedric 2 will be unique. And here select a region, so I will use US Central. Okay, and I will simply now create tenant as written in the instruction. So create tenant should be super quick, and as you can see, it's already green. So my messaging system is started. Now in my messaging system, I need to create some queues for the message to flows. So I will select my e-commerce here, and I will select, click on the topics tab, select default namespace and add topic. So here, namespace, here, default, and here I see the button add topic. Okay, so the topic name here is pending orders. Copy, paste, add topic. And 3 more, picked orders. So add topic, again, here, add topic. Shipped orders, shipped orders. So here is really me following the instruction, making Astra ready to host my app. Okay, I do have now 4 topics. And this is what I ask you for the hands-on one. That's it. We are ready. We have the Astra DB ready to go. Okay, we have the database ready, and we have the messaging ready. Here, so persistence of is persistent. Yeah. Persistent, yeah, Fido. And no need to partition. Partition is the same idea as Cassandra. If you want to distribute the data across multiple machines, but here I can tell you we will have not a lot of data. We don't need to use partition. And when you are done with these step 1 and 2, you know, give me a signal in the YouTube chat. Just maybe say me ready or a send up. Let me give you a send up in the YouTube chat. Also, I will wait for everyone to be at the same state as me. So now is also a good time to ask questions if you have. All right, Nick the tank is ready. Yeah, thank you. Yeah, great. Yeah, you rock. I see we are 61 live. Great. Also, now is the first time to tell you, hey, if you enjoy this content, this interactivity, these technical materials, consider to subscribe to the YouTube channel and like the video. You know, we are here every week. So question regarding the topic tab, when you click on your streaming tenant, here you have one tab called namespace and topic. It is the 3rd on my user. Okay, Hugo is also ready. Okay, I will let you finish, and at the during the same times I will go over a couple of slides. That's the slide heavy part. I explained you about the databases. You created one. Now we will design the data model of our e-commerce platform. Okay, so in the e-commerce platform you will have multiple big business block. You have the product catalog. Here, I mean, if you look on my screen now, you see the online store with the product catalog, the shopping cart for the user to be able, of course, to purchase some item, inventory as the backend to know exactly how many products remain for each reference, the payment block, and the shipping block. So now the way the app I'm showing to you today has been built is we implement one block after another, one after another. And we have been implementing this app for almost 1 year. And as of today, I have 4 big parts to show you: the product catalog, the shopping cart, the user profile, and the order processing. And by the way, this is the latest order processing. That was also needed this streaming broker to send some message. Okay, so let's have a look one by one. And I told you we will start with the data model. So if you have used a relational data model, a relational database, SQL database before, or if you have learned SQL at school, you are familiar with this denormalized concept. You will start with the data. You will have the data only present one time in your schema, and then you will create some joins and relationships in between the table to execute your queries. And you think about it, it is the data first, the entity first, what my employee should look like, what are the attributes, what is the primary key. And you will do that for any entities. And then you create those relations with many-to-many association table if you need. And in the end, as a developer, us, we see the data model, and it is our job to shape and create a request with the good joins, left outer join, inner join, whatever, to query exactly what we need. And it is a normalized data model. Why? Because the same data is only present once, and it's a very organized structures. So here, if I show you employee, departments, in the departments, in one department, you might find multiple employees. So you have a one-to-many relationship between department and employee. So it's great because it's an efficient storage, not a lot of data stored, same data is stored once. Interesting for the data integrity. You cannot create an employee without a department. It's simple to write data there. Now, when it comes to read, you need to get some data coming from multiple tables. And the join can go to what we call n+1 select. So you get first department, and only then you get all the employees for the department. It might feel natural. Yeah, it's just one-to-many relationship. But now, think about the same concept in a distributed system. Now your data is distributed across multiple nodes. So if you need to do a join, you will have to get some data coming from multiple nodes, and each time you pay for the network cost, it's not efficient. And so normalized data on distributed system are slow. So we need something else. We need denormalize. And denormalizing, you might also be familiar with. So if you look at the model, it's the other order. You start with your app. Okay, so this is my app. This is the screen. I will get the list of my product. Each product as a category. I want to order the product by category. If I click one category, I want to see the list of my product. Well, you got your screen, and with the screen, you got all the requests and queries that you will need. And this is based on those requests that you will create the data model. As you can see, the logic is different. start with the app, start with your queries, and build the model based on your queries. So if you look at what the table could look like in a denormalized features, you store together what you want to retrieve together. You can think about join when you save and not when you read. Because here, the one-to-many employee department has been done when you save. These also can be seen as a view, right? If you have worked with business intelligence, data warehouse in the past, you can also see that as a data mart, right? And this is the way we want to develop with NoSQL. We want to think about denormalizing, just to have the same data in the same place, just for the performance, and not the need to join data coming from multiple nodes. So here, fast read, simple data model counts data duplication. And if you need all the employees for one department, this table is perfect. But if you need all the employees for this country, even if you add a colon, I mean, you will group the employee either by department or by the country, but not both at the same time. So you will need another table. Even if it's storing the same data, it's more or less one table, one access pattern, one query. And it's not natural coming from relational. But it's in NoSQL, this is how it works. We consider that storage is cheap, and we will store the same data multiple times with multiple schema in order to be super fast when we use it. So one table, one query, and even if it's not exactly one query, it's one table, one access pattern. Okay, so now in the Cassandra world, there is a methodology to build an efficient data model based on your requirements. And this is the overall process. You will start with the MCD, a conceptual data model. It's very similar to relational, but only that is not enough. Because it's denormalized, you also need your queries. Because your queries, here what we call the application workflow, will tell you how you should group things together. With those two inputs, you can map, and with the mapping rule, you can get the logical and physical data model. So this YouTube channel is really all about Apache Cassandra. So you will find a lot of videos, recordings of 2-hour session just on data model, for instance. But here, what we want to do today is having a running e-commerce app at the end of the 2 hours. So what I will do in front of you is it's not simply, but I will use the methodology, apply the methodology to the 4 business functions we just discussed: product catalog, shopping cart, user profile, order processing. So this is why I told you it will be a slide heavy, because I will have a couple of slides to go through for each use case, and then we go back to the end zone and we simply create all those tables in the database we created together. Okay, so first, product catalog. So we did the work for you. So a product have ID, name, description, price. Okay, this is what we design. And the product is associated with a product category. And it's a one-to-many category to product. Why? Because we want on the user interface to have a menu where you can pick a category, then a subcategory, just to list the product. Again, it's already thinking about what the user interface look like to get our entities. And so the category will have an ID, a name. So ID for unique identifier, name for on the user interface, and a parent, because you may have a parent category like media and you open media, you get computers, and you open computers, you get all the different components, and you click component and you get all the motherboards available, for instance. You can easily understand that you will have a tree of product category. So here, and the user will navigate the product categories. Yes, so far so good. I told you MCD is not enough. You also need the queries. What are the queries? Exactly what I just stated in plain English, or both a mix of English and French accent just before. So the queries you need to be able to access a product by its identifier, get product by ID. You need to be able to query the product by online price, and you need to list the categories, and you need to list the product in a category. Okay, so that's our input. Based on those two MCD and input, we use the mapping rule and we get those tables. X queries, X tables, more or less. So here, get a product by ID. You have a product by ID. Here, the partition key is also the primary key. Providing a product ID, you get all the details of a product. Okay. What about the category? So here you have a category with category ID and the parent ID, image, name, and the list of products related to this category. Category can have, so category by parent, see? So I give you, I don't know, I give you the parent ID computers, and you will give me the category motherboard, screen, keyboards, whatever. Get all the category for a parent. But here I also need parent for a category ID. So here now I give you just motherboard. If you want to go back or go to the category above, you need to be able to do the opposite. So you have a dedicated table. I know this is the first one we are doing. It might be weird if you're coming from relational, but hey, look at the name of the table. The name of the table is actually what you want to query with. Product by ID, I will put the product ID in my where clause. Category by parent ID, I want to put parent ID in my where clause, and so forth and so on. So here, get the price for product ID. So here, the table at the bottom, the 3-1, is a way to have different price for the same product for different store. So here you got a store by its ID, you get the price by store, and you get the price by product ID. Okay, so mapping, then you get to this physical data model where you can reduce the tables because you might think, hey, I'm able to select everything from this table, get the full menu and rebuild that menu. Product by ID, price. And to be honest, in this e-commerce app we are using, it's simplified. So, you know, moving quickly. So the price, separate from product. Data distribution is a challenge for database. I will move. Here is a product with the product ID is our partition key and primary key. And category, we want to store the product by category. And maybe one thing to notice, you know, in relational, when you do one-to-many, you are doing a foreign key. Here, one-to-many, if you look at the table and look at the attributes called product, one attribute can be a list. So one-to-many sometimes can just be done using this trick. Okay, now shopping cart, and I will go faster with those one. You don't need to get the full rationale behind the choice that has been made in the design. just understand the full methodology. So shopping cart, this is what we want to have as a result. So first the entity. A shopping cart will have multiple products. Products still have ID, name, description. Shopping cart also have ID, username, cart name is active. We made the choice for one user to have multiple shopping cart. Sometimes on Amazon, depending on which account is using which people is using your account, the email account, each user from the account can have a dedicated shopping cart. So here it was a way to say one user can have multiple shopping cart and one shopping cart to have multiple products. Okay, what queries do we need to do with a shopping cart? Need to be able to query a user active cart, of course. Give me the product in my cart. That's the obvious one. Need to query all cart for a user. Yeah, give me all the cart and only then I can select a cart to see the product. View all product in this cart. Add and remove product from the active cart. So this one is easy, right? Get the list of cart, pick one cart, get the list of product and be able to remove and delete. Applying the mapping. So here, product by cart. If I give you the cart, give me the list of product. Active cart by user. If I give you the user, give me the list of cart. And this is how you end up with cart products with cart ID as a partition key. So just a more word on partition key, clustering key. I moved fast on the previous one. A primary key is there to ensure the unicity of a record, no different from relational. I show you partition key will code how the data is distributed across the node. And you group together what you want to retrieve together. And this is why cart product, give me the cart ID, I give you the product. User cart, I give you a user ID, give me the list of cart. So you, in between the partition key and the primary key with ensure unicity, we miss something, right? There is something that needs to be added. And this something is called clustering key. So the primary key is the combination of PK and CK. Clustering key are used to sort the data, to ensure unicity, and also if you need to provide these parameters in your where clause, it needs to be a clustering key. It's also a way to index the column if you wish. So 3 values of indexing, because it's need to be in the primary key to have request, sort, and unicity of the okay, so user cart, okay, we get that. Enforcing a TTL, so that's in Cassandra you can have a time to live. When you insert something in table, you can say, hey, after X amount of milliseconds, it will be automatically deleted. And that could be cool for a user cart, right? They create their shopping cart, and after 24 hours, if they do not validate the cart, the data is automatically deleted at the database level. You don't even have to delete the cart, it's just the cart has a time to live. So this is what has been designed here. Cart product, same principle. Okay, and let's go quickly over the 2 others, just to go back into the code and the end zone. User profile, a user have some personal data, okay. Queries, get the user by ID, get the user by email address. So get the user by ID is get the detail of a user profile, get the user by email address, maybe for authenticate. When you authenticate with a user and password, and you want to check a dedicated table to see if the user exists and the password is correct. So single table is enough for this user by ID, and if you want user by email, that's got the second. user profile, here you got it. Password hashing, that's not something only for Cassandra, but of course you do not want to store the password of your user directly in the database. You want to encode the password. This is what we call hashing. What you save in your data is just a hashed password. And so when someone tries to authenticate, you take the string coming from user input, you encode, and you compare the encoded value. This is why it's impossible for an app to find your password. They don't store your password. They only store the encrypted password. And this hashing function is only one way. You cannot go back from the hash password to the original password. I mean, that's the point of it. So user address, user by email. And now order processing, again, same idea, start with the MCD. This time the user will need a couple of address, a user have a couple of cart. We covered the shopping cart before. The cart contains product, and when you check out the cart, your list of products will convert into an order. And for Philo, this is exactly what we will do. We will authenticate using Google before the end of the session. Okay, so now for order processing, you validate your cart, you get a user order, you specify a user order, you want to list the previous order or get the status, and you want the timeline as in be shipped, as in be received, as in be validated. So here is a table, and here is the detail of the table. Again, we provide you the slides. So if later you ask yourself, hey, why this table has been designed that way, you can go back to the slide and see this is the assumptions, so this is the end model. But now, you know, we are 1 hour in, and it was a heavy slide part, so why not going back to a bit of technical stuff. Okay, so back, I switch, and here I will be asked to create the schema. So here you see the 4 business domain, and we will directly create the table we designed. So how to do so? So timeout, for security reason, I need to sign in again. So let's sign in again using Google again. Okay. All right. I will pick my DataStax Dev Workshop organization, which is the one we are working with today. So we are using the database called demo. So I will select the database by clicking here demo. And here in the details of a database, you see multiple tabs. Else to see monitoring, connect with multiple ways to connect to the database using APIs, using binary connection, using SDKs. For now, we don't use it. We will go to SQL console. So SQL means Cassandra query language. So how to interact with Cassandra. And actually, I will even click on open in new tab. Why? I just want my SQL console is full screen for you to see my screen and be able to use a bigger font for everyone to follow. But here again, not rocket science. In my database, I have multiple key spaces. So if I describe key spaces, you see I do have system key spaces and one business, which is the one we created together. So here what I need to do is to put the focus on the key space. So to do so, I will use e-commerce, and you can see that the prompt here has changed. Now I have e-commerce in the prompt. Okay, so far so good. if I describe this key space, for now it's empty. We did not create any table. So key space. Here I just have the instruction to create the key space. Oh, just notice that it's one ring with 3 nodes and the replication factor. So the data is replicated 3 times. Okay, so now let's create the table. So here I will copy the block. So to copy the block on GitHub now, on the top right hand corner, we can click there and it's copied. And it will start creating the table. Okay. And I think you can even execute that multiple times, because here it's called if not exist. So if you create another time, it will be skipped. Now I can use describe tables and see we have created the different tables for our 4 business use case. Okay, once the schema is ready, you want to save some referential data. You know, in the user interface, we want to have something to show. So for that, we have prepared for you a couple of data. And here, so for the category in the menu, so here we see clothing with the ID, image already ready to go, and the parent category. So actually here you see flat category, but it's already a tree with multiple layers. So same, I'm going here, copy that block, paste, and it will start creating all that. So, category, price, product. Okay, and product feature group. Okay, right. So now select star from category. You know, I told you right in the beginning, select star in a table without a where clause. You know, I said, oh, what I'm doing here, I will do a full scan of my cluster. It's not good. So it's not a query that you will run in production, but for the purpose of this demo, it's good enough, right? So select star, and here I got my result from the category. But if you remember, describe table category. So this is our category table. We have parent ID, category, image name, product list, and primary key. So the partition key is parent ID. So if I want to get the first level of the menu, I would say select, not star. Let's just put maybe here the name of the category. So select name from category, where parent ID, equals that. So it's not magic. You just say, hey, so it's grouped by parent ID. Here we told you that the very top category is this guy. So when I will start the app, my top level menu will be that. But now if I get the same query and I would like to get the closing, you know, the closing ID. So I will not only select the name, but also this time the category ID. Category ID. So here, clothing has this value. So now if I want to see everything inside clothing, you got it, I will just use this as parent ID. And the user interface will do exactly the same. About the equal sign. Here we go. So now inside clothing, I have hoodies, t-shirt, jacket, and I will... Is this guy French? Yes, Jordan, I'm French. All right. Keep going. Okay. So the data is now there, pre-populated. To start coding now, I mean, it starts to code, right? You need some credentials. As of now, you see I authenticated using Google user password. I need something else. I need some credentials for my app connect. So to create some credentials, I'm going here and I will go to man organization settings. It's written there, organization settings. Okay, and here I will pick token management. So here, really following the same principle, and I will generate a token. So here, select a role, organization administrator, generate token. Okay, and you know this token, you really want to save the token and save it for later. So let me save it on my second screen here. Client ID is here if I need it, and client secret here, because for security reason these identifiers are shown only once. Okay, all right. Okay, I created a token, I paste my token, and I save my token locally. I did not download the CSV, but it is on my second screen and I can copy back them when needed. View the Astra teaming connection details. So if I go back here and go back to my streaming tenant, if I go to here and see the different details, where are the details now? Oh, here it is, tenant details. Okay, so when I will connect my app to this database, I will have to provide a token, database ID, and URL. Everything is in the user interface. Okay. So let's go. Okay. So now we created a lot of entities in the database and in the streaming system. Let's start using it in our code. So let me move that here, that here. Here we go. So now we need an ID. Which ID will you pick to have both JavaScript and Java? VS Code, right? VS Code is very good. I don't want you to install VS Code. We do have VS Code in the cloud, and it's called GitHub, free as well. So here I right click, open in a new tab, and so up I will move GitHub here. So GitHub is actually initializing right now, and it works for any GitHub repo. It's just amazing. So here I see all the files available in my GitHub repo. I'm in the cloud, okay, web-based IDE, and I have full access to both Java and JavaScript. So I will let the environment finish to initialize, and I could start working. So here it's a full VS Code, right? So here it's installing a couple of things. So here, clear. Okay. So it opened the README right into my IDE. That's cool. Here I do have a terminal. I will probably make it bigger for everyone to see the command I'm using. On the left part, I see the code, so I can just go to the backend, source, main, Java, open the code and start coding. Okay, so it's a full-fledged IDE. I can start code. I also have access to the unit test. And here, maybe we have not even started to do anything, right? And look at that. I do have Maven, okay, available. I do have Java. Maybe here. I do have NPM. Okay, I do have Node as well. And nothing to do. I also have Docker if I want. I don't need that for today, but it's there as well, right? So consider that GitHub, it's free to use and very good for any demo or stuff that we need some tools. It's just there and it just works. Okay, know your GitHub. We did that. We can now move forward. So enter the token. So if you look, okay, let me close that. If you look here, we have a file called .env.example. Yes, with the keys that we will need. This is what we need to set up to connect our app to everything we just created together. So here, what they ask you to do is to execute that command, to copy that file. Oops. To copy that file, the first time you need to paste, you allow that. Okay. So now I do have this file.env. So this is what I need to have in my dot. Yeah. Okay. And now our goal will be to populate this file, right? So Astra database ID. Well, if I go back to Astra user interface, database, here, let's go to the dashboard. So database demo. So here, this is the identifier of my database ID. Here, database ID. Copy. Go here. Paste. All right. Database region. I will shut. No, I will leave that. Alors, database region. I will click on my database here. As of now, I do have a single region. Remember, I told you with Cassandra, you can have multiple data center across multiple regions, have the data as close as possible to your user. You do that by creating multiple regions. Here I do have one, so let me copy the name over here. Or the token. Remember, it's the one starting with Astra CS, the one I copy on my other screen. DB Keyspace. I mean, it has been asked in the beginning of the session. So e-commerce, if you change e-commerce to something else, put something else. Streaming tenant. Okay, this is where I'm going to my tenant. Here with all the values. So tenant name, e-commerce Cedric 2. Here we go. Stream URL. So he explained before what stream URL should be. It's the broker service URL. So let me go here. Broker service URL. This one. So I copy here using that icon. Okay. All right. And now Astra stream token. So this time I'm going into token manager. Oh, wow. Token ID never expire. Can I just copy my token here? Let's see what it looks like. Not sure I can copy the token. Yeah, it works. Okay. And Google ID, Google secret. For now, we don't have it. So let's put it dummy. I want to start the app as soon as possible. So let's put some invalid values in client ID, client secret format. Let me copy paste that somewhere else. I will need that later. Okay. All right. So it seems like I populated this file as we expect. So now I copy the command source. You know, source is the Linux command that will get all the values and put them in the environment variable. So I say source.env. Okay. Now if I list all the environment variable doing env, and I look for the one starting with Astra, and you see that it's there. So any app would use those values now. Okay. Oh, it was okay. It was there. All right. Okay. So what about now testing the connectivity? Can our backend app connect to the database? So the backend does have some unit tests. So here I will close env, close. If I go to now, it's still 2.2.6 Spring Boot starter. So to have a REST API, Swagger UI to expose a web client to be able to interact with the web UI. We will use that later. And to connect to Astra, we are using Spring Boot starter, data Cassandra, and Spring Boot starter Astra. So with these starters, the heavy work will be done for us. So use Pulsar and stuff. Okay, so what we are told to do is go to test and execute test1 connectivity. So if you look at connectivity, what the test is doing is using that object Astra client that will load the connection and list the database in our organization. So now is the moment of trush. I'm in the proper folder. I mean, Maven. Oh no, I need to go to the backend. Make sure I'm in the backend folder. Okay. Let me go here, big. All right. Clear. ls. Okay. And now I will try the connectivity. Okay, so it's a Maven command, so it will download half of internet. That's expected. You will download all the dependencies needed. Okay, so it ran this test, and I see here in the output, this is the database available. Workshops and demo. Workshop was running before, and we created together a demo. This is the list of product categories. So it was able to connect to my Keyspace, connect to my table category, execute the statement. So it seems like the backend is configured, is properly configured. If we look at the initialization, yeah, we just see that SQL session is enabled. But okay, just validating that the backend is properly connected. Okay, now how would you map the object in your backend and the table? What we call object mapping. In the relational world is done by Hibernate or GPA in the Java world. One object, one table, and doing ORM, object relational mapping. Here in NoSQL, there is no relation. So we simply call that object mapping. And to do object mapping, we are using a framework called Spring Data. So to use Spring Data, you create in your app some object. So here let's pick the category. We are working with the category. So you create a hide you stuff. You will create an object and you annotate the object with anything needed to map your object to the Cassandra table. So here mapping the table called category, and this is how you map some tables with the object. Once the mapping has been done like that using annotation, you create something called a repository. And the repository is simply an interface, so not an implementation. You just define what you want to do, find by key parent ID, and this is a framework that will actually execute the proper SQL queries for you under the hood. You don't even have to write it by yourself. That's how powerful now the object mapping framework. So what we want to do now is simply test this class to see if the object mapping is working. So here, closing all that and simply copy this test Spring Data. I will let it running, and at the same time, maybe I can open the class. So here we just say it's a Spring Boot test. I want to load the category repository, the one I just showed to you, and I will just use the function find by parent key using one identifier, and I will get the list. And if it's successful, in the console, I will show you category, and I will use the data loaded by Spring Data in the console. And this is exactly what you see here, actually. So here, closing wall, take accessory, client mug. This is the loop that has been done for each category. So here you saw category, and then one row for each category. So, okay, we are able to connect to the database. We are able to do the mapping between the table and the object, the service layer, if you wish. On top of the service layer, now we need to expose an API, because what the app will need, the web app will need, is a way to access your backend through an API. Spring Boot expose provide Spring MVC. You create controller. So long story short, if I go here to category services, you will find one called REST controller. And if you look at the code of your REST controller, it will inject the service category repo. It will expose an HTTP endpoint. This is your REST API. And then it will expose get parent. This is a way to interact using HTTP. So it's a lot of annotation, just declaration. And so it's all that is, so that's the mapping. That the documentation to be able to generate a web-based client with something called Swagger. And this is your code. So here, get me the parameter from the HTTP request. Use the service we just defined together, and provide the output of the service in the output of the HTTP request. If it's not found, give me a 404, HTTP not found error code. So response.not found. But if the category exists, give me all the category for this parent ID. And if you look at the code, this is just what we do. We invoke the category, providing the parent ID, and we want the list of category. So again, it will be the same request, give me the category given a parent ID. But this time, we are directly invoking the HTTP API. So HTTP up to service, up to object mapping, up to SQL, up to the database. And if this test is successful, we have the backend fully wired to expose an API. Okay, so here are our categories, but this time these categories has been retrieved from the REST API. Cool, not too bad. All right. You know what? Let me start the app, right? Even before this enable social. I want to start the app. You know, and also I want you to stay with me up to the end, right? And as of now, it was only code and code and code. What about the app, right? So here I enter a command. You don't have to do it right now. I just say gitpod does not expose all the ports like 8080, 8081, and I need that 8080 to start my app. So there is a command called gp url 8080 to say, hey, gitpod, what will be my URL if I want to start something on 8080? And this is what it gives you. So here, I will go here. So expecting, right? Our app is still not running. But if the app is running and the app is working, we should be able to see the app here. So here, let's start the app, right? So I'm going into the app and I will just, so here, so Maven install is actually build me the deliverables. Okay, and start.sh is actually the script to start the app. So let's do start.sh. So it's starting. Okay. So the app is starting, the app is connecting to our databases as we discussed together. It seems to have completed the initialization. Oh, look at the tab here. Oh, it seems like we are not doing too bad so far, right? So the app has been started. Here I have my e-commerce. I can get the detail of one product. So what have we done? Product, give us the categories, closing, and give me the subcategories of closing. So what the user interface is doing is just invoking the same HTTP API we tested together just to get that part. But if you do that for all the categories, this is what you get. Right? You get the same for all the categories. That's the product catalog. When I click on one product here, so I get the product list for a category. Okay, you got it. And if I click one product, I get the product details. So with that, I can do product catalog. But I'm not authenticated, right? I cannot sign in. And if I cannot sign in, I cannot do shopping cart because I need a user. I cannot do user profile because I need a user. And I cannot do order processing. So two ways to do it. First, create a dedicated services just for user authentication, or reuse as Philo discussed before, use Google to authenticate in our app. What if you can use Google to authenticate in the app, right? In the end, your user, this is what they want to do. They do not want to register with a new user to your app. Okay. So let me shut down that. So if I just go in 2 minutes in the slide, what we just did with application code and backend, for each use case, we had a list of queries to be available for the user interface. We make the data model just to match those queries, and we create a REST API to match the same queries. Retrieve all orders by user ID, plus an order, retrieve the user status, retrieve data for a specific order ID. And if you tick one of those, retrieve data for a specific ID, it is a function that will take an order to get all the details for an order. This is what the SQL queries look like under the hood. And we did that to get order by user ID, all the history of an order ID. Okay. So now come the part when we need to authenticate, right? Using Google or something else. And if you jump into our app, what we just did is we used the Cassandra drivers to connect to Cassandra. We use Spring Data Cassandra to do the mapping object tables. We use Spring MVC to export the REST API. What we could do now is use Spring Security, leveraging Google SSO to do the authentication. So let's try to do it together. This could be a bit bumpy, so let's see how much we can do. Okay. And after this ends on 4, we could play all together again. So we are good on time. Let's go. Okay. So yes, Philo, of course, this session is available at the same URL for free a couple of minutes after the session. It's recorded. Because sometimes I probably move too fast and you want to take your time, especially if you are doing things at your own pace. And when you keep moving, think about doing the screenshot. Remember, at the end, the homework is just sending the screenshot to Aaron to see where you are to get your badge. Okay, so so far so good. Now we need to authenticate in the app. And if you remember that environment file, I put do me and do me. Obviously, I could have tried to sign in, but it will just fail because, of course, it's not connected to Google. So how do you connect an app to Google? So to do so, you create, you use Google Cloud Provider, and you go to the Google Cloud Console. Put the Google Cloud Console here. Okay, so this is my Google Cloud Console. And as you can see, I already have a couple of client ID. So here we will create a 002 client ID, and we will refer this client ID to the app running in GitHub. So how do we do that? Well, we follow the instruction blindly. Okay, so first, consent to use the API. This is something I've already done. So OAuth consent screen here, OAuth internal. I already have validated that. Okay. So edit app. So maybe I can here maybe I can do a new project. Okay, so for the project, let's do live e-commerce. Let's see what I can do with that. Okay. Okay, project is creating. Okay, I select that project. Okay, user type internal and create. So far so good. Okay, so now if I look at the different screen, application information, so let's say e-commerce workshop, support user email, I will put mine, app logo, for, you know, beg your pardon, I will not put any image. You know, this image is the image that pop up when you have the screen to authenticate with Google. So app domain, here we go. Make sure the project is set up by internal. Okay, yeah, I do that. Make internal, okay. So save and continue. Email address, okay, need my email address. I will give you my email address. Okay, save and continue. Okay, so make internal, all right, or auth console, okay, we good. Make external, internal. No, I think we are. Make sure the project is set up for internal. I think we're good. Make internal, I think we're good. So now let's go to credentials, because hey, this is what we need, right? Now we need to create client ID, client secret, a way to connect to this app. So here, credential, create credentials, and I need a OAuth client ID. Okay, application type, web application. Okay, so far so good. It's a web app. So name, web e-commerce. Okay, let's call it that like that. Okay. And now look at that. The screen of Google Authentication will pop up. Will ask you for which account you want to use in Google, and then you will be routed to your app. So Google need to know where to route the request, and it needs two things: the JavaScript origin and the redirect URL. So let's see. Those values are the one here. They will look like something like that because you are using an app in GitHub. Long story short, no need to think too much. The command has been provided too. So here, authorize Java origin, this command. Okay, so here is exactly what I need to put here. Okay, and for authorize redirect URL, same. We provide you exactly what you need to have here. Here, 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 and this is what I need to have. So far so good. Add URL. Okay, and now I simply, maybe simply is not the good word, right? I click create. Okay. Client ID, client secret. Oh, I think this is what we needed, right? So if I copy my client ID and go to the file .env, let's see, client ID and client secret over here. Okay, now I save. So Google is set up. Have a new app called Web App E-commerce that will route the output to Gitpod because we provided Gitpod URL in the setup. So now, if everything is okay, I should start the app again. So this one, no big problem. I'm pretty sure that will work as you expect. So start.sh. But now we hope that authentication is working. So far so good. Loading, live loading. It's not at initialization that you try to connect to Google, so it will not tell me if it's successful or not yet. I still have the app ready to go. Company, product. I can go back to the home. Okay, it is. Okay, that's the home page. All right. So now login. Sign in with your account, so Google. Okay, so here the app is called e-commerce workshop because this is the one we have here, e-commerce workshop. We did not put any logo. This is why we don't have any logo here. So let me put this, and voila, I'm not connected with a Google account into the web app. So if you go here, you see that he has picked my user and password, user first name, last name, coming from my Google principal, Google credential. And now that I'm authenticated, I do have access to the function of the profile as I just showed to you, but also if I pick one, I'm medium, I can add to cart. Okay, it has been added to cart. I can probably also pick some a t-shirt. I like this one, medium, add to cart, and go to my cart. And here I do have my shopping cart. Here I can place my order. And here in the output, we should see that when I place my order, a message is triggered. And we interact with the order processing table. Okay, so with that, we covered a lot, and we were successful on the first attempt to set up our app and connect our app. So what about the front end? We did not really talk about the front end, right? So the code of the front end is here. You have the user interface, so it's a React, so package.json. We are using Tailwind CSS for the different part of the UI. Okay, it's a React DOM. So here you have the Tailwind config and the different source and layout, and here the components of your screen. Okay, everything is a component in React. So here you have the loading, you have the navigation as the component, the flyout menu. So it's a React app that we can start with, you know, node start and get the node rolling. You may notice that we were able to start our app without Node. How is that possible? Well, this is how you will ship and package and deploy your app. This Node project that you build with React, you will render this app as a vanilla JavaScript, and when the site has been rendered, is simply vanilla JavaScript and HTML. And once that's the case, you can copy all that code and put that code in src main resource static. And here, what you see is in static is actually the code of the web UI that has been rendered as a static HTML. Okay. And this is why when we start the backend, we immediately have a user interface without the need to start the user interface. Okay. But again, if you are a front-end developer, not like me, and want especially to look at the front-end code, here it is full working, and just even in VS Code, you can start the front end using Node. Okay, so with that, we covered the technical content for today. So check the APIs available. I did not try the APIs. I could have tried the API, but hey, the full app is running, so obviously the REST API is working. So do a screenshot of your working app, because this is what you will need to send to Aaron. And with that, 10 minutes left. I think it's a good time to ask you a few questions, right? Let's play a game together. Did you pay attention? So, you know, let's see. A couple of things maybe I did not mention before is the message broker we use to send message is called Apache Pulsar. I think I talk about it, but you know, I know what are the questions coming, and I also know that a little help is always welcome. Okay, so let's do a quiz with, you know, 5 small questions. So if you join not at the beginning, to play the game with us, go to menteecom and enter the code that you see on my screen, or the QR code. Oh, I'm just on top of the QR code. So, maybe I can just let me yes. Okay, now I'm not on anymore. Live editing of the stream. Okay, all right. So let's see. We are 20 and on 40 concurrent views. So I think we can go. And let's have fun and be on time. That was my commitment with you today. Just be on time. So 6 questions and 23 participants. So the fastest you answer the question, the more points you get. So answer fast to get more points, to lead the way. And also check your screen or mobile phone first, because the YouTube stream probably have a delay of 1 or 2 seconds. Question 1. What is Astra DB a better choice for e-commerce than relational database? Because it scales better, because it distributes the data, because it's region awareness, reduce the latency to your user, all of the above. Hey, yes. So this one was to put a smile on your face. Okay, everybody is right. Yeah, it's scalable, it's distributed, it's region awareness, and of course all of the available as well. So let's see who was the fastest. So DevSeed with great question today for us, and was also early at the stream. So, you know, thank you. Question 2. And for fast to get more points. What is the importance of the partition key? Just another key, no importance? Probably not. Help support app, access pattern, distribute data across nodes or data center. Another name for the primary key. Not too hard, I guess. Yeah, good. So most of you get it correctly. Distribute the data across the node. Okay, a primary key will contain both partition key and clustering key. Okay, let's see. Let's have a look at the result. Hey, Cassandra, we see some familiar name. Thank you for coming back. Stix Eduardo, yeah, always good to see people back. And now Stephens leading the way. Okay, question 3. If I fast to get more points. Which part of the primary key keep data ordered within a partition? Probably just clustering key, composite key, unique key. Yeah, okay, good. Yeah, in the question before, I just remind everyone that the second part of the primary key is called the clustering key. What a competition! Look at that. So now Rakuma was the fastest and now take the lead. Woohoo! Great. Okay, 3 more questions to go. What are the technologies used for the front end? Vue.js and TypeScript, Angular and Dart, React, Node.js, Tailwind. Not sure, copy-paste from Stack Overflow. For the front end, okay? So Vue, TypeScript, Angular, Dart, React, Node, Tailwind. Yeah, Ranjit Kumar got it. Yes, React. Okay, this one not too hard. I mean, in 2 hours, it's so many content to show you that question cannot be too difficult. All right, 2 more questions to go, and this time it's the backend. What are the technologies used for the backend? Java and Quarkus, Java and Spring, Python and Fast API. I'm not sure. Copy paste from Stack Overflow. Yes, it was Java and Spring. Good. Who was the fastest? Hey. Oh, that was tough. It was a speed question. And Stix was the fastest. Okay, last question, everybody. Who paid more attention today? Who is the best? What is the technology that powers the event-driven messaging and streaming capability in Astra? Spark, Flink, Pulsar, all of the above. Yeah, I mentioned it just before the quiz and also at the very beginning. It's Apache Pulsar. So Spark is a distributed framework to do the compute, and Flink is a competitor of Spark. Pulsar is really the message bus. Okay, who is our big winner for today? And Raj Kumar stay up to the end at lead. So congratulations. So I keep this form open if you want to tell us what we could improve, or if it's good or you like or did not like. And with the 2 last minute, I can simply share with you some resources. So if you want to get the badge, submit the homework. This is the email address that you need to send your screenshot of running app just to get the badge. With, you know, multiple screenshots just to see that you have completed the function. But if one is working, probably the others are also working. If you want to reach out to us after the session, we are on Discord. So here is a link. 20K people in that Discord. So if you have any question on programming, keep there asking question. We talk about Cassandra a lot today. Just for everyone to know, there will be a Cassandra Submit next year in March in San Jose. This is the date. If you can go, please go. If you know a little bit about Cassandra or using Cassandra at your company, consider to submit a talk. Always good to have new folks and more folks at these events. And with that, we're just on time. But before closing, hey, if you stay with me up to the end, maybe that's the good time to register to the channel, put a thumb up or leave a comment in the video. We are there every week at the same time, and the topic change each time. Last week it was introduction to GraphQL. Next week it will be, if I'm not mistaken, next week it will be using Apache Airflow, so a distributed system as well. But you know, nevertheless, hope you enjoy the session, the format, the interactivity, and if I don't see you until then, see you next week. Have a good one. Bye, everybody.